Hello, I'm Terry. I'm a rising senior at ES Prep Southwest, and this is my final project. Final project and final video. It's the Electromagnetic Floater. It's what I have. How it works is I have only two things that I need to control with the Arduino. So the Arduino is the brain of the whole, shebang. It controls the electromagnets. I can control which way the electrons are flowing in the wire by changing which one is high, which input is high or low on the Arduino IDE. And it's powered by a 9-volt battery because the electromagnet, it has a range of 6 to 12 volts. If I exceed or go below any of those, it's pretty bad. I like my life. I don't like bad things. So, well, it's bad. Okay. I got the electromagnet working. It picks up different things. I'm just putting little bolts onto here. It's not a very strong magnet. I can put small objects on there. It'll just keep attracting to it, and yeah. For the H bridge, I had there's one side for inputs, and then the other side is for outputs, right? So on the H bridge, it'll have PWMA, AN2, AN1, and then standby. Those are the 4 pins that I'm using there, that I'm using mostly on the H bridge. And then there are 2 more at the bottom out of the 8 total pins on that column. So the last 2 are PWMB and ground. So PWMA and standby are rooted high, and then ground is connected to ground on the other side, on the output side. So I have PWMA and standby rooted high, and then ground is connected to the grounds on the bottom of either side are connected to each other. So from the Arduino, I have 5 volts. I have 5 volts running to VCC. Sorry, I have 5 volts running to VCC, which is on the output side of the H bridge. Oh, sorry. Yeah. So the H bridge is right here right here. The H bridge, it has eight columns on either side. So 8 pins on either column, which is on either side of the H bridge. So on the output side, it's not PWMA. It's ground, then VCC, then A output 1, then A output 2, and then it goes on to B output 1 and 2, and then it goes to ground after that, and VMod. So with I have the 9-volt battery connected to VMod and ground. So that's where the that's how the whole system's being powered, along with the 5 volts coming from the Arduino into VCC to power the H bridge. So my main struggle was soldering, making sure that wires weren't touching where they need to be, wires weren't touching where they didn't need to be, so I wouldn't short the battery. And I tried to make the board I was using seem like a breadboard to make it simpler, for me to understand. But it's a lot more complicated if you do that way. I wouldn't recommend it. So it's being powered by the 9-volt battery and the Arduino, and then I have ground on the Arduino running to the ground on the H bridge. So ground is the first pin on the left side of the H bridge when you have the circle at the top. So yeah, my electromagnet works, and the things I need to work on for it to actually, you know, to float objects at a specific range is the coding. So I needed it to turn on and off extremely quickly for at a certain distance away from the electromagnet. So I'll have the photo sensor, the photocell that I have here. It it detects light. It as light is, you know, is reaching the photocell. It'll the resistance will change, and based on the change in resistance, I'll have a reading of the I'll have the values given to me if I look at it in the serial monitor. So my problems were mainly lied in soldering and having the Arduino coding getting you know, set up. So with soldering, it was just making sure that, you know, wires that didn't need to be touching weren't touching, because if I there was a point where I had my power and ground connected, I was shorting the battery. So if you ever, you know, do that, that's pretty bad. My other problem was with coding. So with coding on the on the Arduino, I had I had some problems with having my photocell detect light. So I had I would need the electromagnet to turn on and off really quickly during, you know, a given interval. So like I started out with 200 times per second, and it didn't really help me if I didn't have my my photocell. So my photocell, it as light hits the photocell, it changes resistance, and I would get the different values on the serial monitor on the Arduino IDE. So based on the values that I get from the photocell, I can I can I can change the values in which, you know, like if it was giving me a reading of 756 at like 2 inches away from the electromagnet, I would say, you know, turn on and off for 200 times per second. So if the distance between the electromagnet and the object, whether it's metallic or magnetic, if the distance increased between the electromagnet and the object, I would need the electromagnet to be on for a greater amount of time. So I'd have to change that in the Arduino IDE, and then if it was getting closer to the electromagnet, I would need to you know, leave the electromagnet off for a greater amount of time. So that was one of the problems that I ran into, and that would be my next step, to have, you know, an LED and a photocell working simultaneously with the electromagnet to get to be able to read the height. I mean, to be able to read the height in which they should be floating at. And that's my main project. Thank you for watching.